Okay, in this video, we are going to look at powers of 10 notation, also known as scientific notation. It's a really convenient method of writing very large or very small numbers. Okay, commonly what you have is a non-zero number in the front, and you express that number in two parts. Okay, so two different parts. The first part is a value that's greater than or equal to 1 but less than 10. Okay, so in this case, the number is already in that form, so we're going to write 1.157. Okay, that coefficient is then multiplied by a power of 10, okay, in order to achieve the number that you had originally. So this case is actually very simple. The only number you need to multiply this by itself is 1. Okay, and in order to get 1, that's 10 to the 0. So 1.157 expressed in a power of 10 notation is 1.157 times 10 to the 0. Okay, moving on to part B, 21.9. Again, the first number is a digit between 1 or greater than or equal to 1 but less than 10. Okay, so the first number is going to be 2.19, okay, times 10, and the exponent that goes up here in the corner. Okay, it's the exponent needed to move this decimal point to the right in order to get this value. Okay, so if this decimal moves to the right one space, we will get the value 21.9. Therefore, the exponent is 1. Okay, part C. So here you've got 0.0067. Okay, so the number that's between 1 and 10 that we're going to write is 6.7 times 10. Now the exponent here, because this is a number smaller than 1, the exponent here is going to be negative. Notice here how these numbers were bigger than 1, so the exponent was greater than or equal to 0. Whenever you have a negative exponent for the 10 multiplier, that means the number is going to be very small, usually a decimal less than 1. Okay, so here, if we had the decimal right here at this point between the 6 and the 7, we would have to move it back 1, 2, 3 times to get to the original decimal place. Therefore, the exponent is -3. Okay. Part D, 28.635. Okay, so the digit to express this in between 1 and 10 is going to be 2.8635 times 10. Notice in this case, we only had to move the decimal over one spot. So here, in order to get back to the original number of 28, we simply have to move the decimal to the right by one spot. Okay, therefore, this is going to have the exponent 1. Okay, moving on, part E, 0.216. Okay, expressed initially the coefficient between a number of the 1 and 10. You're going to have 2.16 times 10. Here, if you had the decimal here, you would have to move to the left one space. Therefore, the exponent is -1. And finally, part F, 333. Okay, so the number between 1 and 10 is going to be 3.33. Don't drop any of the numbers unless the question actually tells you to. Okay, because you are given a level of precision in the problem with whatever numbers are given to you, so you want to keep that level of precision. You're just expressing the number in a different means. Okay, so 3.33 times 10. If you had the decimal right here, you would have to move it to the right 2 times. Therefore, the exponent is +2. And if you want, just do a quick check. Okay, if the number is greater than or equal to 1, the exponent should be 0 or greater. Okay, it should not be negative. Okay, if the exponent is negative, that means the number is a small decimal less than 1. And sure enough, it is. Okay, so that's it for this video, guys. If you enjoyed it, be sure to give that like button a click. Subscribe to this channel so that you never miss a video from Physics in the Flesh. Thanks so much for watching.